One of the things we're going to look at is NAND gate substitution. So we're told that we can replace any other gate with NAND gates. We can also replace any other gate with NOR gates, but we'll do NANDs for now. Now to replace an AND, we replace it with two NANDs. So if I were to take A and B not, and I need to invert it, so I'll run through another NAND gate I set up as an inverter. So out of this, I'll have A and B not, and then after this, I'll get A and B not, so they'll cancel. I replace an OR gate with a NAND inverter in each side into an AND, into another NAND. So these set of gates right here replaces the OR. I need to go back and do my C. It goes through an inverter, so I just run it. Set up a NAND gate as an inverter. So this is the inverter, produces C naught out. This is my OR gate, and then finally I'll have one more NAND gate to replace that inverter. So logically this should do the exact same as this. We can even try it. So right here I'm going to take this and invert it, A and B not. I'm going to take this, C not, invert it, and I get a C. Out of this gate right here, I'm going to get A and B not and C not. Alright, so I do this, and then invert on the way out. And then out of here, I'm going to just take this and invert it. So I'm just going to end up with A and B not and C. Now, if we walk the De Morgan's theorem, we can see this is going to be the same as this, because I can take this statement we had earlier and say A or B not, invert all of it. By De Morgan's theorem, I can replace this OR with an AND, so A and B and C naught, and then not over both of them, which leaves me with A and B naught and double negative C and C. Same thing I have with my NAND gates. Okay, I've done my NAND gates up here, and I have 1, 2, 3, 4, 5, 6, 7. So it does seem like I have a more complex circuit. However, these two NAND gates are both inverting, so if I just get rid of that one and get rid of this one and run C directly in, I have the same thing. Likewise, I have two inverters in a row right here. I can get rid of both of those. So when I'm done, I can end up writing this as A and B naught through that NAND gate, C, and then I'm going to run them both just right into a NAND gate. So out of this, I'm going to have A and B naught and C naught, and then I'm going to run through one last one to get that inverter. That's this one, which will leave me with A and B naught and C. So in the end, I can replace this circuit with 4 gates with 3 NAND gates. Even more importantly, I can now build this by putting a single NAND gate onto my board. So I have one gate with one IC with 14 pins instead of 3 ICs with 14 pins each. I have one IC drawing power instead of 3 drawing power, and then I can use 3 gates out of that same IC. So if I look, the 7400 is quad to input NAND gates, so I can take it and build it with 3 NAND gates inside. So that's what I'm going to do. I'm going to take my board. I've still got my other integrated circuits sitting on it. What I'm going to do is just bring it over. Place it here. We want to find that 7400 IC. It's going to be very hard to read. I don't know if you can, but 74LS00 sets to 7400. I'm going to put it right in here. I'm going to go get a short little black wire and a short little red wire so I can get some power to it. I'll leave everything else hooked up for now. The others I'm not going to do anything with at this point. Just no point in disconnecting them all, so I'll just let them sit there. They're not doing anything. You may notice in this case, I'm going to go ahead and just hook it up and leave power on. Would encourage you to do that all the time, but once you get confident with it, there's no reason not to, because nothing's going to happen until I have both power and ground. So I'll hook that up. Anytime I'm not sure, put your finger on it. If it gets warm, it'll get there quickly and you'll feel it and you'll realize it's not comfortable, because I'm not comfortable and I should turn the power off and check what's going on. Okay. Get my ground. Warning on this breadboard: if I tried to put ground right here and over on this side, there's a disconnect, so there's no ground running across. I'd have to run a little wire across to connect the two sides. That's so you can have different power supplies on the two halves of the board if you need to. Allow some flexibility. So I'm just going to make sure I get it on this side and get power to this. Then I'm going to take a couple of these long wires and just test my NAND gate. So I'm going to run them up to A and B and into my NAND gate. And before I do anything else, I'll just test it. So I'm not even going to worry about hooking up all the rest of my circuit. So I should be good. So the NAND gate, 0 NAND 0 is a 1, 0 NAND 1 is a 1, 1 NAND 0 is a 1, 1 NAND 1. I mean, that'd be 1 and 1 would be a 1 with an output of 0. And then the others would all produce a 0, then you invert it and get a 1. So I'm working fine. So if I disconnect this one, this input to this NAND gate is this NAND gate. This NAND gate. And then I'm going to take that output of that NAND gate and run it into another one and C on the other side. So what I'm going to do is I'm going to make this C. And what I'm going to do with it is I'm going to just run it directly into the next NAND gate. Right there. I'm going to take a little short wire, relatively short in this case, since I used it earlier. I'm going to take the output of the first NAND into the input of the second. So what I've done is I took C into a NAND gate and this output into this input. So if you look here at my NAND gates, I've used these two, A and B go into 12 and 13. The output of 13 is going to go directly into 10. Output goes directly in. 9 I brought from my switch C. 8 will be the output of that NAND gate. And it's going to go into another one that's just going to act as an inverter. So what I'm going to do now is I'm going to just take this output of this NAND gate. I'm going to take it over to the other side of this set of NAND gates and into the input. And I need to hook both inputs together, so I'll get myself a little short wire for that. This wire is not one to strip, so if you're wondering what the delay is, that would be it. Okay, it's fighting me. About got it. Sometimes these shorter wires are a little bit hard to strip if you don't have pliers handy, which you have at your workstation, but I didn't happen to bring when I set this up. So we're going to try this. And all we're going to do is connect our two together. Finally, I'll take the output of that last NAND gate, that's that inverter out, and it just needs to go up to my light. Reach, stretch that one, see if we get there. Now we're going to go through and test it and see if things are working. So if I had all zeros in, I'm expect to get a 0 out. 0, 0, 1, I get a 1 out. 0, 1, 0, I should get a 0 out. I do. 0, 1, 1, I should get a 1 out. 0, 1, 1, I get a 1 out. 1, 0, 0, should get a 0 out. 1, 0, 1, 1, 0, 1, should get a 1 out. 1, 1, 0, should get a 0 out. 1, 1, 1, should get a 0 out. 1, 1, 1. So I test it, and so my single IC with 3 NAND gates produces exactly the same logic as using 4 gates, 2 hex inverters, an OR and an AND, using 3 ICs. So now I've done my NAND gate substitution. So it's just a way to simplify things. And we always need to start with our basic circuit, substitute NAND gates, and then we're always going to have redundant NAND gates when this works well, so we're going to have to go through and look for we have inverters that we can cancel out.